2009 Physics Senior External Exam and Paper 2, Question 7. A 22 gram metal spike is fired at a velocity of 300 meters per second into a block of wood suspended by two strings of negligible mass. The spike remains embedded in the block. So this is a conservation of momentum problem. The initial momentum of the bullet will equal the final momentum of the block. The kinetic energy of the block after the collision will then be converted into gravitational potential energy as the block swings up. The impact of the spike knocks the arrangement sideways and it rises through a vertical height of 32.5 centimeters from its original position. Use this information to determine the mass of the block of wood. Okay, so we have the mass of our bullet, 0.022 kilograms. We have the mass of our block, 0.0325, sorry, that's a height. My apologies. The height is 0.325 meters. Now, the actual solution here to the problem, let's draw our diagram. We have the initial momentum of the bullet, P initially equals the mass, 0.022 multiplied by the velocity, which is 300. Now, that will equal the momentum of the block and the bullet. So the final momentum will be 0.022 plus the mass of the block multiplied by whatever velocity they move off at. Now, that will also have a kinetic energy. The kinetic energy will be a half times the mass, 0.022 plus m, multiplied by the velocity squared. That will be totally transferred into gravitational potential energy here. UG will equal to mgh. Now the mass is 0.022 plus m, multiplied by 9.8, multiplied by the height, 0.325. Now that will equal that. And we have our third equation here which equals that. And therefore we can go through and solve simultaneously. To look at the solution provided by the examiner, let's have a look. Mass of the bullet, 0.022. Initial momentum of the bullet, 300. Height through which the block rises, 0.325. Since the momentum will be conserved in the collision, the initial momentum of the bullet, 6.6 kilograms meters per second, will equal the momentum of the bullet and the block and whatever velocity they move off at. It should be much lower than 300 because of the mass of the block. The kinetic energy immediately following the collision will be converted into potential energy. So the kinetic energy of the block and the bullet will convert to gravitational potential energy as it swings up. So we can go through and say half mv squared equals mgh, cancel out the masses and solve for v. So v is the square root of 2gh. So the velocity of the block and the bullet after the bullet hits it is 2.5 meters per second. So we can substitute that back into this particular equation here. So the initial momentum of the bullet, 6.6, is equal to the final momentum of the bullet and block, which is their masses added together multiplied by their velocity, which we calculated from the energy equation. And when we go through and we solve this, we get the mass of the block is 2.6 kilograms.